Welcome to Fluid Coding and AI. Today the test is not whether we can write an agent loop, we can. The test is what happens after that loop has to work on a real repository. Plain Python gets us control. Pydantic AI v2 promises capabilities, ToolSearch, CodeMode, tracing, evals, and gateway routing. So the question is simple: does the abstraction remove real overload or just move the plumbing somewhere with nicer names? The inner loop of an agent is almost boring now. Call the model. If it asks for a tool, run the tool. Put the result back in the conversation. Repeat until it returns an answer. Pydantic's own v2 announcement says that basic loop has basically settled. The interesting layer is around it: instructions, tools, hooks, context management, steering, and loading the right behavior at the right time. That is why this comparison has to be about the harness, not about who can write the shortest while loop. The plain Python version starts beautifully. A model call, a list of tools, a dispatcher, and a history list. It feels honest because nothing is hidden. For a repo agent, the first draft might expose read file, search, edit file, run tests, and maybe list directory. That is enough to fix a toy bug. And honestly, I like this version at first. You can print every message. You can add one more if statement. You can pretend this will not become a tiny operating system by dinner. The clean version stops being clean when the repo task becomes real. Now we need a file system root. We need approval rules for destructive edits. We need prompt packing so tool schemas do not flood the first request. We need retries, trace spans, token budgets, resume state, test verification, and a way to score whether the agent actually solved the task. None of that is exotic. It is just the difference between a notebook demo and something you can run twice without crossing your fingers. Here is where my expectation changed. I thought this would be a framework versus no framework comparison. But the more useful question is narrower. How much behavior does the model need to see before it can act well? Pydantic's capability docs warn that tool selection starts to degrade when the visible tool set gets into roughly the 30 to 50 tool range. That is the repo agent problem in miniature. More capability can make the model worse if all of it is dumped into context at once. In Pydantic AI v2, a capability is the unit of agent behavior. It can bundle instructions, tools, lifecycle hooks, model settings, and sometimes native tools. That matters because repo access is not just a tool. It is a policy, a root directory, a set of allowed operations, maybe approval hooks, maybe logging, and maybe instructions about when to run tests. So the best argument for capabilities is not that they make code look fancy. It is that related runtime behavior can move together as one named piece. The important feature for tool overload is deferred loading. With deferred loading, a capability can start as a short catalog entry, instead of pouring all of its instructions and tool schemas into the request. When the model needs it, it loads the capability, and the full bundle becomes active for the rest of the run. That is the right shape for a repo agent with many workflows. The model does not need every possible GitHub, file system, eval, and code execution instruction before it knows what task it is solving. There is a catch, and it is not a small one. Pydantic's docs say deferred capability instructions are returned through the load capability result and land in message history. That can include copies serialized to client-facing adapters. So if an instruction must stay server-side, do not hide it inside a deferred capability and hope for the best. Keep that capability always on or design a separate policy boundary. Deferred loading is a context tool. It is not a secrets manager. ToolSearch is the other half of that story. Pydantic docs say ToolSearch handles deferred tools so large toolsets only pay tokens for tools the model actually needs. On Anthropic and OpenAI responses, it can use native server-executed search. On other models, it falls back to a local search tool. That means the Pydantic version can treat tool discovery as part of the runtime instead of another hand-rolled prompt filtering system. The caveat is prompt caching. Changing visible tools between turns can affect cache stability depending on the provider path. CodeMode is the capability that sounds the most like cheating, in the useful sense. Instead of making the model call list files, then read a file, then search, then read another file, then parse test output across a chain of model, Visible tool turns. CodeMode exposes one run code tool. The model writes Python that can call multiple tools with loops, variables, conditionals, and async gathering inside the sandbox. For repo work, that can turn noisy back and forth into one compact result. But CodeMode also makes the runtime more serious. Pydantic's docs say it is powered by the Monty sandbox. Anthropic and Cloudflare make the same broader point from their own code. Execution work. This pattern can reduce token waste and intermediate tool chatter, but it requires sandboxing, resource limits, monitoring, and careful handling of credentials. So the honest verdict is not CodeMode makes agents safe. It is CodeMode can reduce model turns if your execution boundary is real. Once the agent is doing real work, transcripts are not enough. Pydantic Logfire integration can instrument Pydantic AI, so each run gets traces with spans for model calls and tool execution. The docs also describe OpenTelemetry support, which matters if your team already has an observability stack. For a repo agent, this changes the debugging question. Instead of, why did the transcript feel weird, you can ask which tool ran, which model call expanded, where time went, and what the provider request looked like. This is also where Pydantic Evals becomes more than a nice extra. The docs frame an eval around datasets and cases. Each case has inputs, optional expected outputs, metadata, and evaluators. You run the task across cases and get a report with outputs, scores, and assertions. For this comparison, that is the tiebreaker. Did the agent solve the repo task? How many model calls did it need? Did it run tests? How many tools were visible on turn 1? Could we rerun the same cases after the framework changes? Gateway is the provider routing part of the Pydantic stack. The docs describe one interface for multiple AI providers managed through Logfire, with key management, spend limits, routing groups, failover, observability, and native provider request formats. For a repo agent, that means provider choice, cost controls, and failover do not have to be welded directly into the agent loop. That is useful. It also means another product surface to configure, monitor, and trust. Cleaner plumbing is still plumbing. So where does the comparison land? A plain Python loop is still the clearest way to learn the mechanics and the easiest way to control every weird edge case. For a small, fixed toolset, it may be enough. Pydantic AI v2 starts to make more sense when the repo agent has multiple workflows, many tools, code execution, tracing, evals, provider routing, and policies that should compose instead of sprawl. Capabilities do not remove runtime design. They make the runtime easier to name, load, observe, and test. That is a useful abstraction, but it is not a permission slip to skip the hard part. If you are building repo agents, the useful question is no longer, can I write the loop? It is, can I control the harness around the loop? If this helped clarify where Pydantic AI v2 is useful and where you still need engineering judgment, like the video and subscribe to Fluid Coding and AI.